Hi, my name is Cale Rowan, and I'm a member of the Human Interactions and Programming Group at MSR Redmond. I'm going to be showing you a demo of Code Canvas today. So what we have here is a project that we've taken from Visual Studio and imported it into a big canvas. So you can see all of the files that were in the project, all of the code within those files, and you can even see the relationships between those files based on the class inheritance of the classes within them. So all these edges are like a class diagram, and they're your standard inheritance arrows. You've noticed here also, or you may notice, that it's organized by folders. So there's one main project folder and one subfolder within it. If we don't like the layout, or we want to rearrange things based on like tribal knowledge of the team, we can move things around, and our MSAGL layout engine will keep them in roughly the same spot that they want to be, while respecting where you placed individual items. And you can even change the grouping. So say I want to take these abstract classes up here, and instead of viewing these by folders, I want to create a group and just call it abstractions. And then our layout engine will make sure to keep all those together while keeping everything else out. So at the heart of Code Canvas, what you can do is you can zoom in and out of your code. So you can see all of your code at once. When you zoom all the way in, you're basically looking at a code editor. As you zoom out, then the code gets smaller, but certain things stay the same size so you can read them, like the members of classes. So here we've got a class name, a private field, and some of its members and properties. As you zoom out even further, eventually things will have to start giving way. So we do things like make the private fields go away first. And so as you zoom out, all of the private and protected ones have gone away, and all you're left with is the public ones. Once you've got a layout like this, you can do a bunch of interesting things. For example, search results become more interesting. Instead of as a list, you can see them all over your canvas. So let's say I search for the definitions of name. So you can immediately see on the canvas, all bright yellow, all of the spots that define name and that also reference that property. You can also do things like, instead of doing go to definition and bringing up a brand new code editor and you may get lost, you can just click on the name of a class, for example, and then see a green arrow pointing to exactly where it's being referred to by, or where it's referring to. So if we zoom in here a little closer to see what's going on, this green arrow was given down here because there's a parameter, this function of the type that I clicked on. So now that I've zoomed in, you may have noticed that the arrowhead has gone off the screen, and now I can no longer see what it's pointing to. So we have this option you can turn on to automatically generate a preview of the end of the arrowhead, so that you don't actually have to move the canvas to see what it's pointing to. And if you do want to go there, you can just double click the preview and it'll take you right there. And then what you're left with is a preview of where you just came from. You may also notice that the search results are still visible on the screen. You can still see a few that are actually in your view, but at the edge of the screen are the ones that aren't visible anymore. So you can tell that there's 3 results this way, a couple results down this way, and that really helps when you've got spatial memory generated over all of your code. Another thing we can do is show execution traces that touch multiple code files at once without getting you too lost. So here what we've done is we've run this program and taken a log from it and captured it into this timeline up here that you see with the slider. So here's the main function of the program, and as I slide the slider across, you'll see it start to run through its main function and make calls into the other parts of the code. With these the arrows that are traversing the code. I can show this in more detail in a project that will all fit on one screen. So here what this is just a simple console application that is like a paint program but for ASCII art. And we ran it by passing square and diamond as an argument. So we can see here's the main function up here. And as we scrub the timeline through, we can see that it goes in its loop, it checks its argument, sees a square, it creates a square, sets a property on the base class, and then it calls the abstract paint method, which happens to execute the code over here. Goes back in this loop, now it gets diamond, creates one of those classes, same property on the base class, but in the same abstract call, goes down to this diamond class. So it's, you know, the classic polymorphism visualized in a pretty new way. You can take this, you can also see in this example the code coverage results. So the red and green blocks of code represent the code that was missed by our run or our test. The green code is stuff that was hit, and the darker the green, the more it was hit. Another example of this is with multiple threads. So in this program, this comes from a tool called Chess, which is also an MSR tool, and It's demonstrating a data race condition. So we have just a bank account here, and it's showing how you can exploit it to generate as much money as you want. So up here you see two sliders, the green one and an orange one, and each one represents a thread, but they're linked. So as I slide time across, you'll see the green thread start doing some actions, and then the orange thread will take over and start doing some actions. And then as you keep sliding, the sliders will be linked and they'll alternate, so you can easily see the thread interaction between a multi-threaded program. If you'd like to, you can go to HTTP Code Canvas and download these 3 projects and also import your own. We'd love to have feedback. Thanks.